So we all know climate change is happening, right? But what if I told you the planet itself has a built-in accelerator pedal, one that's getting pushed harder and harder every year? Today, we're going to dig into the hidden engines of global warming, these incredible chain reactions that actually cause the climate to feed on itself. Okay, let's get into it.
Yeah, forget thinking about this as a simple, straight line of dominoes. I want you to imagine them arranged in a circle, where that last domino doesn't just fall. It knocks over the first one all over again. It creates this relentless, self-perpetuating, and, this is the key, accelerating cycle. And that's the reality of the system we're actually dealing with.
So, what do scientists call these self-perpetuating domino effects? Well, there's a specific term for them. And honestly, understanding it is absolutely key to grasping the speed of what's happening to our planet. They're called feedback loops. Think of it like this. The climate system is basically having a conversation with itself. You get an initial whisper of warming from, our CO2 emissions. That causes an effect. That effect then causes another, which circles all the way back and turns that initial whisper into a full-blown shout. It's this feedback that really determines whether the system can stabilize itself or if it just spirals.
Okay, so you've got two flavors of these loops. Negative feedback loops are kind of like the planet's safety valve. For example, a little more warming can create more low clouds, and those clouds can reflect sunlight, which produces a slight cooling effect. But positive feedback loops, they're the amplifiers. They take one small change and just blow it up. And the problem is, these positive amplifying loops are really starting to dominate the system.
All right, enough theory. Let's see how these loops actually play out in the real world. First stop, the Arctic. This is where a really powerful, and actually pretty simple, feedback loop is already in full swing. You can literally see it happening from space. This picture illustrates the cycle perfectly. It all kicks off when rising temperatures melt the bright white sea ice, which for ages has acted like a giant mirror for the planet. This exposes the dark, deep blue ocean water underneath. Now, we all know dark surfaces absorb heat, while light ones reflect it, right? So the ocean starts soaking up way more of the sun's energy. That warmer water then melts even more ice from below, which exposes even more dark ocean, and you see where this is going. The cycle just keeps repeating, faster and faster. And the numbers here are just staggering. Albedo is just the scientific word for how reflective something is. Sea ice reflects a whopping 50 to 70% of the sun's energy straight back into space. But the open ocean? It reflects a mere 6%. That is a massive difference. So as the Arctic's mirror gets replaced by this dark surface, it's transforming from a planetary air conditioner into a giant heat-absorbing sponge. So from the frozen north, we're going to go global. We're going to look at the planet's entire circulatory system, a huge, powerful force that governs weather patterns all over the world. And yep, it's also falling victim to these feedback loops.
And this is a pretty terrifying question, because these loops don't just happen in a vacuum, right? They're starting to mess with the very systems that have kept our climate remarkably stable for thousands of years. So what happens when the very heart of our climate system starts to fail?
What you're looking at here is essentially the planet's heating and cooling system. This massive ocean current, called the thermohaline circulation, moves warm water from the tropics up to the poles and then brings cold water back down. It is the reason Northern Europe isn't locked in a permanent deep freeze. Seriously, without this, the climate as we know it just wouldn't exist.
So how do you break something so enormous? Well, you attack its engine. You see, the whole system is powered by cold, salty water getting really dense in the North Atlantic and sinking deep into the ocean. But as Greenland's ice melts, it's pouring unbelievable amounts of fresh, less dense water right into that engine. It's kind of like putting the wrong fuel in your car. The engine sputters, it stalls, and the entire global system starts to grind to a halt. The potential result? More extreme winters in Europe and shifting storm tracks in North America.
And just to be clear, this is not science fiction. This has happened before. It's history. At the end of the last ice age, a massive glacial lake burst and flooded the North Atlantic with fresh water. Sounds eerily familiar, right? The conveyor belt slammed to a halt. So the frightening question is, are we now pushing that same system towards the same cliff? Just look at that number, a 10 degrees Celsius drop in Greenland's temperature in just a matter of decades. That is a climate shift of almost unimaginable speed and scale. It's a really stark reminder of how violently and how quickly our planet's systems can change once a tipping point is crossed. But the story doesn't stop with ice and oceans. Scientists are now uncovering a newer and in some ways an even more alarming connection. A dangerous dance between fire and ice that could be creating a kind of supercharged feedback loop.
So first, you have to understand that the Arctic permafrost is a ticking carbon time bomb. This frozen soil holds around 1.6 trillion tons of carbon. That's double what's currently in our entire atmosphere. For thousands of years, that carbon has been safely locked away in a planetary deep freeze. But now, well, that freezer is thawing out.
As the permafrost thaws, microbes that have been dormant for millennia are waking up, and they are hungry. They start to decompose all that organic matter, releasing huge plumes of carbon dioxide and methane. It's like opening a Pandora's box of greenhouse gases. And of course, those gases cause more warming, which thaws more permafrost. It's another one of these vicious cycles, with no easy off switch.
But here's the real game changer. For a long time, we thought of Arctic wildfires and permafrost thaw as two separate, though related, problems. We now know they are actively feeding each other. Wildfires, which are now burning hotter and more often, are incinerating the protective insulating layer of soil and moss that sits on top of the permafrost. This allows summer heat to penetrate deeper and faster than ever before, accelerating the thaw in a way that creates a new, supercharged feedback loop that our climate models are only just starting to understand.
So we've seen these dominoes falling, right? Melting ice that absorbs more heat, a slowing ocean that changes our weather, and now a dangerous new cycle of fire accelerating a thaw that releases even more greenhouse gases. So why is putting all these pieces together so critical right now?
This is the bombshell. The crucial point here is that the very tools we are using to navigate the climate crisis might be broken. These feedback loops, these accelerators we've just been talking about, are either completely missing or they're severely underestimated in many of the models that governments use to set policy. We're making decisions that will affect generations to come, based on incomplete and frankly, dangerously optimistic data.
So let's just recap the story we've uncovered here. We started with the simple idea that the climate can accelerate itself. We saw it in action with the Arctic's melting mirror. We saw how this is starting to disrupt the entire planet's circulatory system. And we've just learned that new, entangled risks are emerging, these connections that our best science is still struggling to fully capture.
And all of this leaves us with the most urgent question of all. These dominoes aren't just falling, they're setting themselves up to fall again, faster every single time. So if our fundamental math is wrong, if we're ignoring all these accelerators, we aren't just underestimating the problem, we might be trying to solve the wrong equation entirely. The real question is, what do you think the new equation should look like?